Hello everyone, welcome to part 3 of session 3 of module 4, specification based or black box test design techniques. In part 3 of specification based or black box test design techniques, we will learn about state transition testing and use case testing. So what is a system state? A state is the position or situation that a particular object or system is in at particular time. So for example, if your car is standing and not moving, it's in stationary state. Once you start the engine of the car, apply the gear and accelerate it, it starts moving. So the state of car changes from stationary to moving. Then what is a transition? A transition describes the way in which system moves from one state to another. So for example, when the car started moving from stationary to dynamic, to when it started moving, then what we did, we started the engine and put on the gear and accelerated. So transition describes the way. So what was the way when the car started moving? We started the engine, put on the gear and accelerated the car. So that's the transition. System moves from one state to another based on the inputs applied to the system. So based on the input that we apply to the system, the state of the system changes. Mapping these changes in states and their transitions are the basic parts of state transition testing. So how to create a state transition diagram? So if you see the diagram in the left, there are two states, state 1 and state 2, and starting state. So state 1 and state 2 boxes specify the current state of the system. Then the transitions from one state to another is shown by the arrows. So these arrows show the transition from one state to the other. And then the event is the input which must be applied to achieve the required state. So the event will be the input that you apply to achieve the required state. So for example, the car is initially in stationary state. So let's take an example that car is in state 1. And once you start the engine, put on the gear and accelerate, so that's the event which moves the car from state 1, from stationary, to state 2, that is moving state. All right, and the action is the outcome of the applied input. So what event you did, what input you did to the car? You started the engine, you accelerated the car, and what was the action or the outcome? The car started moving, and the state of the car changed from state 1 to state 2. So that's how you create state transition diagram. You have certain states, you connect the states, you transition the states from by using arrows, and then event is the input which is applied to achieve the required state, and action is the outcome of the applied input. Now let's take an example of state transition testing. So let's take a bank ATM example scenario. So suppose you want to withdraw some amount, $500 from bank ATM. You may be given cash for the first time if your bank account has balance. After some time, you again try to withdraw $500. You may be refused the money. In case your bank account doesn't have sufficient fund, you will be denied to withdraw $500. This refusal is because the state of your account, initially there were $500, but since you withdraw on the $500, the state of your bank account changed from sufficient funds to insufficient funds. And the transaction, the initial transaction, the withdrawal of $500 that you did initially caused change in the state of your bank account. So a state diagram can represent a model from the point of view of the system or customer. So let's create a state diagram for this example. So here if you see, the initial state is the start state, wherein you insert the card. Okay, you go to the ATM machine and you insert the ATM card in the machine. Once the card is inserted, the state changes. The state of the ATM changes. It waits for the PIN. In case you enter the PIN and PIN is right, you directly get access to your account. That's another state in the ATM software. You get access to the account. Now you get access, you see the balance in your account. Now if you withdraw all the balance that you have, $600, then the state of your account will change from having sufficient funds. You will get $600, but the state of your account will change to insufficient funds. Now if you again try to withdraw $500, you will get error message that you do not have sufficient funds. You have insufficient funds. Okay, so if you are in insufficient fund state, no matter how many times you try to withdraw, you'll always get insufficient funds message. It will just loop over here. Now if it is waiting for the PIN, you enter the wrong PIN, it will again ask you to try again. And if you enter the right PIN the second time, you will get access to the account. If you again enter the wrong PIN, it will remain in this try again state. So that's a bank ATM state transition diagram. Now, what are the basic parts of state transition model? A state transition model has 4 basic parts. Let's understand what are those parts. The states that the software may occupy. So for example, your account may be funded, that's one state. Your account may be insufficient funds, that another state. Or you might be granted access to the account, or you might be asked to retry the PIN in case you have entered wrong PIN. So these are some states of the software. A transition from one state to another, that's another basic part. So when you try with correct PIN, you transition from one state to access to your account. So that's the transition from one state to another. So that's another basic part of state transition model. Then the events that cause the transition. For example, when you withdraw the amount from your bank account, you had $600, you withdrawn all $600, that withdrawal caused transition from one state to another. That withdrawal caused transition from having sufficient funds to insufficient funds. So the actions that result from a transition. So the last basic part of state transition model is the action. So the action that resulted from a transition. For example, an error message or you being given your cash. So if you have sufficient funds, you try to withdraw, you will be given the cash. That's action of the event that you did, withdraw fund. But if you don't have sufficient funds, you will be given an error. So that's another action. So these are 4 basic parts of state transition model. Please note that in any given state, one event can cause only one action, but that the same event from a different state may cause a different action and a different end state. So for example, once you are in sufficient fund states, withdrawing money from that state will give you funds. But as soon as your account state changes to insufficient funds and you try same event, you are trying same event of withdrawing amount, then the result that you are getting, the outcome is different. So it depends. It's not necessary that same event will give you same result in all the states. So the results, same event will give you different actions based on the state of the system. So deriving test cases from state transitions. So state table is very useful for deriving test cases from state transition graph. So the graph that we discussed, ATM graph, then you can use state table to derive the test cases based on that state transition graph. So state table lists all the states down one side of the table and all the events that cause the transition on the top. Each cell then represents state event pair. So this state transition table is very helpful in deriving the test cases for your from your state transition diagram. So what we have done is, here in the state table we have list all the states in this column, state 1, 2, 3, 4, 5, and the actions or the events that we took on the top. So insert card, invalid pin, valid pin, withdraw $600. All right. So now if you see the test that we can do is, so if you're on state 1, that is start state, and you insert the card, you will move to state 2, that it will wait for the pin. Now if you are on state 2, this insert card is not valid, so it's just not applicable. Then at state 2, what are the transitions that you can do? What is valid scenario here? So it's waiting for pin. If you enter the invalid pin, it will move to state 3, that try again. But at the state 2, if you enter valid pin, you will be granted access to your account, that is state 4. It will move to state 4. Now if you are at state 3, if you enter invalid pin, it should remain at state 3. If you enter valid pin, you should granted access. You should get access to your account to state 4. Now if you are at state 4, you withdraw $600, you move to state 5, that is insufficient fund, because you just had $600. If you are at state 5, insufficient funds, and you try to withdraw again, you will again remain at insufficient fund. So under state 4 and state 5, invalid pin, these scenarios are not valid. So once you are at state 1, start state, this is invalid pin is not valid. State 4, this is not valid. Valid pin is not valid. So all these tests here, all these blocks here are not valid. So you can, using this state table, you can figure out what are the transitions that you need to test in the software. Now let's see what is use case testing. So before understanding what is use case testing, let's see what is a use case. A use case is a description of a particular use of the system by the end user of the system. So it's basically how the end user will use a particular software system. A use case is a description of that end user interaction with the software. Use cases are a sequence of steps that describe the interactions between the user and the software system. Each use case describes the interactions the end user has with the software system in order to achieve a specific task. So each use case describes the interactions that user will have with the software in order to achieve his specific task. Then what is a use case testing? Use case testing is a technique that helps us to identify test cases that exercise the whole system on a transaction by transaction basis from start to finish. So use case is basically a kind of business scenario or end-to-end scenario that end user will perform with the system. So use case testing is a technique that helps to identify how the system will behave, will exercise based on the transaction by transaction basis from start to finish. Use cases are defined in terms of the end user and not the system. So use cases are defined in terms of end user, how the end user will interact with the software, what operations an end user will do. So it's not based on the system. Use case describe what the user does and what the user sees rather than what inputs the software system expects and what the system outputs. So the main focus in use case testing is how the end user will interact with the software and what he is expecting out of the software, rather than like in functional testing you provide some input and you expect some output. You are not testing any of those things. It's just the end user scenarios, what user is trying to do with the software and what he's expecting with the software. Then use cases use the business language rather than technical terms. So use cases use business language rather than any technical terms. Each use case must specify any preconditions that need to be met for the use case to work. So each use case has to specify any sort of preconditions that need to be met in order to use case to work. So if there are any preconditions that has to be set, then those has to be specified. Use case must also specify any post conditions or observable results and description of the final state of the system after use case has been executed successfully. So it should specify precondition, it should specify the output or post condition as well. Then a set of use case make up functional requirements of a system. So in use case testing, a complete set of end user scenarios or use cases makes the functional requirement of the system, and the developers implement those use cases into a working software. So what are the benefits of use case testing? Use cases capture systems functional requirements from an end user perspective. So what an end user is actually expecting from the software, use cases capture that in the form of end user or business users requirement. The requirements are in the form of business use cases, what end user wants from the system. And it actively involves end users and stakeholders in the requirements gathering process. Since requirement gathering is a set of use cases defined, so all the stakeholders and end users are kind of involved in requirement gathering process. Then it serves as the foundation for developing system test cases. Use cases are the foundation for developing any sort of test cases for the testing. So to conclude, in this session we'll learn about following black box test design techniques. We learn about state transition testing. We saw different examples of how state transition testing can be done. We saw how to create state transition diagram and state transition table, and then we also saw use case testing and what are the benefits of use case testing.